Welcome, geometry students. Today we're going to learn how to find and apply surface area of pyramids and cones. Alright, so let's first talk about pyramids and cones. Keep in mind, as a reminder, pyramids and cones both have a base and then triangular sides that meet at a point. So when we're talking about pyramids and cones, that's going to be the common theme today, is that rather than having two bases, they have one single base and they meet at a point. It says the surface area of a regular pyramid is the sum of the area of the base and half of the product of the perimeter of the base and the slant height. So that formula is S for surface area equals B plus 1/2 PL, where B is the area of the base, capital P is the perimeter of the base. We've heard those before in the previous formulas. And then L is the slant height. This is a new value we have not been using up until this point for surface area. So be very careful. The slant height is where the height is on a slant. So it's going to occur on the side. So if you look at the picture, the height of this triangle is the slant height. So we are not talking about the height of the whole pyramid. We're talking about the slant height, which is the one on a slant, and it's going to be part of the side of the actual pyramid. Example 1 says to find the area of each lateral face of the regular square pyramid. Well, since it's a regular square pyramid, that means all four sides are the same. So in this case, each of the four sides is 90 centimeters. What we need to consider is we're trying to find the area of just one lateral face. The lateral faces are everything but the base. So since this is a square pyramid, all of the faces will be the same triangle. So it would look like this. So I'm basically just drawing this particular triangle. Well, we know the bottom is 90 centimeters, that's the base. And then the slant height is what they're pointing to, is L. We would need that slant height because that is the height of this triangle. So what we need to consider is what information do we have in order to find the slant height? Well, we know the whole base is 90 centimeters. This point right here is the midpoint of the base. So then from there to the side length would be halfway. So that makes this 45 centimeters. So what we're going to do is use Pythagorean theorem using this 97 centimeter height, the 45 centimeter base of the triangle, and then we're going to use that to find the slant height, which is this measurement here. So 97 squared plus 45 squared is equal to the slant height squared. Go ahead and pause the video to find the slant height. Alright, you should have found that the slant height is about 106.93 units. If you did not, just make sure you combined your like terms correctly and that you square rooted to find L rather than the quantity squared. Now that we know the slant height, that, keep in mind, is this measurement here, which is also the height of the side of the triangle. So if I come back to my original picture, I now know that this is 106.93 centimeters. So since my ultimate goal is to find the area of this triangle, I'm now going to do the formula for area of any triangle, 1/2 base times height. The base is 90, and the height is the 106.93 because that's the same as the slant height. So if we calculate that, we're going to find that the area is about 4,811.84 centimeters squared. So what that means is the area of each one of the triangular faces on the lateral surface area has an area of 4,811.84 centimeters squared. So there are 4 of those triangles, each of those having the same area. Example 2 says to find the surface area of a pentagonal pyramid. So we know it's a pyramid because it meets at a point, and the pentagonal piece tells us it's a pentagon for the base. So we're going to find the surface area using the formula, area of the base plus 1/2 the perimeter of the base times the slant height. It's really important that you choose the correct formula for the figure. So anytime you have one single base and the faces meet at a point, we're talking about using this formula. So now we know we need to find the area of the base. In this case, the base is a pentagon. So just like before when we were dealing with prisms, we drew the base, you're going to do that same thing here. So here's our pentagonal prism, and it does tell us it's regular. So we are going to look at our picture and put the information that we know. By the way, it tells us it's regular because it's showing 5 equal angles and 5 equal sides. So we are going to use the formula for the area of the base, 1/2 the apothem times perimeter. That's an old formula we've used last unit as well. Well, the apothem is shown, that's this measurement here, and it's 7.6 feet. So the area of the base is equal to 1/2 7.6 times the perimeter. Well, it tells us that each side length is a length of 11 feet. So each one of these 5 sides is 11 feet, making the perimeter 55. If we calculate the area of the base, we should find that it is equal to 209 square units. Now we also need the perimeter of the base, but we've calculated that already when we found the area, and that is 55 because there are 11 equal sides, so 11 times 5 makes a perimeter of 55. Now we want to be careful to use the slant height. And the slant height is this measurement here. It's the height on a slant, so we know that to be 14.2 feet. So now we have the parts that we need for the formula. So the surface area equals the area of the base, which we calculated to be 209, plus 1/2 the perimeter, which we found to be 55, times the slant height, which we calculated to be 14.2. If you complete that, double check that you are doing this accurately, we should find that the surface area is 599.5 feet squared. And keep in mind, when we're calculating surface area, we're calculating the area of each of the faces and combining it. That's what this formula does for us. And that gives us the total surface area of the shape. All right, now we're going to talk about the surface area of a right cone. Well, we actually use the exact same formula for this as we do for a pyramid. So again, because we have one base rather than 2, and we have the side face meeting at a point, it can use this formula. So B is still the area of the base, just like it was in the previous formulas. P is the perimeter of the base. And L is still the slant height. Be careful not to use the perpendicular height. We want the slant height, which will be along the outer part here. It shows it, where this is the slant height. Now, the only thing that makes this problem a little bit different from some of the pyramids we've already seen is that the base is a circle. And in this case, it's a radius of 3 meters. So we're going to use what we know about circles. Our job is to find the surface area of the right cone. So we're going to start with our formula. We know the area of the base, since it's a circle, is calculated using pi times the radius squared. Well, pi times the radius of 3 squared is in exact form 9 pi. The perimeter of the base is simply the circumference. So 2 pi r is how we calculate the circumference of a circle. So perimeter equals 2 times pi times the radius of 3, which again in exact form would be 6 pi. The last unknown we need is the L for slant height, and we are given the slant height here as a length of 5 meters. So now that we have the 3 parts that we need, the area of the base, the perimeter of the base, and the slant height, we can plug it into the formula that we have. So surface area equals 9 pi plus 1/2 the perimeter, which we found to be 6 pi, times the slant height of 5. Check that you can calculate this with me. We should be finding the surface area to be about 75.4 meters squared. Go ahead and try your You Try Nows and bring your questions to class tomorrow. Thanks for joining me, and have a good day.